Now we're going to discuss projections. Projections separate a directional drilling program from a survey program. Projections allow us to extrapolate ahead of where we currently are. We can either extrapolate to a target and arrive at that target at a particular inclination and angle, or we can extrapolate away from us 30, 40, 100 feet as far as we want based upon tool faces, or we can extrapolate with a straight line. There are a lot of things that we can do with projections, and learning how to use them can greatly simplify the work that a directional driller has to do, particularly in the more complex wells that are now currently being drilled around the world. WinServe gives us two basic methodologies to go ahead and calculate our surveys. One of them is with the Curve 21 projections that you can get to by going up to this menu item and seeing curves that we have here. We have a straight line to measure depth, we have a straight line to TVD, we have the build and walk to MD, we have an inclination and azimuth at TVD or plane, which is a methodology that we can use for doing horizontal projections, although there are many other ways that are just as good or perhaps a bit easier. We have the Ouija board calculator, so named after a calculator that I think Eastman Whipstock invented back in the 70s. And then we have the DLS projection to target, which is the same as the slant well or J well. We have the vector project to target, a very powerful tool that we can use to either plan S wells or to do alignment on targets. 3D to formation line is a legacy projection that has been used for doing horizontal projections. Vectored curve is one that I'm probably not going to discuss. It's very, very thin. We have special projection setups which allow us to be able to automate certain kinds of projections. So that's one place where we can do our projections. And then the next place where we can do our projections is with this screen right here. And this is a graphic methodology for doing target-oriented projections. Note that there's a differentiation between different general classes of projection. There are projections that, for example, the straight line projection, you can say you want to go ahead 1,000 feet, and they'll project with the same inclination and azimuth down to 1,000 feet. Or you can say that you want it to go to a particular TVD, and as long as you're not at 90 degrees, it will project to a new TVD for you. And then you have your target-oriented projections, and those are like the DLS projection to target, and those are defined by providing some parameters and a target point that you want to reach. And there are different levels of complexity in each class of projections. The Ouija board projections are of the first type where there is no target that is provided, but you define where you want to go by the parameters that you want to use. This graphic is only for, this graphic-oriented projections is used only for the target-oriented projections. And when you come into this screen, what you have is this zoom bar right here, and it allows you to be able to zoom up and down and where you are. Currently, I have a target which is selected here, which is in the middle. And if you look over here at the left, you can see that this is a target which is at 8,000 feet TVD, and that as I move my cursor around here, that we see these numbers over here are constantly changing. This target over here, even though we know this circular target is at a deeper depth, is not in the center, so its TVD is not being registered when I move my cursor over there. We will learn later on how we can use a projection to go from where we are here to a point here so that we are pointed directly at the center of this target, a very powerful and useful tool for us. For right now, what we're going to do is, the first thing we're going to do is we're going to select the kind of curve that we want to make. And I'll start by teaching the graphic projections, because if you're not familiar with some of the nomenclature, you can visually see more rapidly here what these projections do than you can by doing the tabular method that we have under the Curve 21 projections. First of all, let's talk, before I go there, let's talk about what curve we're projecting from. We can project from two curves in WinServe. We can project from our work curve, which is the most common curve that we're going to project from, or we can project from Curve 21, which is where our projections are stored. And by doing so, by being able to continue projecting from Curve 21, we can construct a series of projections that are all hooked together, and thus we can create a well plan. That's what we want to do. We have to copy that well plan over to a non-volatile curve later on, but we still have the ability to create a well plan and a very powerful set of tools to do it with. Right now I'm coming into here, and let's go take a look at our target. Let's familiarize ourselves with that again. We're here, we have a square target at 8,000 feet. It's oriented at a 45-degree closure direction, and it's 1,838 feet away from us. Below that, we have a circular target at 9,500 feet, and that target is in a slightly different closure direction and a slightly different, well, quite a bit different, a 3,000-foot departure away from the surface. And note that I have target 1 here and target 1 there. That's these are the things that you look at when you're using this tool. When you come in and you use this tool, you should have a little mental checklist in your head. Number 1, can I see where I am? It's often if you come into the target, you may only see the target right here, the screen right here, and then if you want to see where you are, you can see where you are. This crosshair over here is where we currently are located. You don't see any surveys coming off of here because the surveys that we have are all vertical, but there are verticals underneath that red crosshair that's right there. So what we're going to do now is check, the checklist that you need to go in your head is, okay, what projection do I want to use? Basically, it defaults to using your DLS mouse, which is the slant well projection. And by saying your DLS mouse, what it's saying is that we can move the mouse around and we can change the target coordinate that we want to go for. We don't have to go just for the center of the target. And that's a powerful tool when we're trying to, say, bear a little bit to the left because we think that we're going to be walking, and we really, early on, we want to choose a target point somewhat to the left so that we'll walk into the middle of the thing by the time we get there. Another powerful use of it is simply we may have a target that's not really something we want to hit, but something that we don't want to hit. So by defining the shape, we can continue to make a pathway that will allow us to avoid it. So in your DLS mouse, when we choose things up here, what happens is that we also down here have to specify the parameters that we want to use. And the DLS is a slant well, which means that we have a build section and that builds until it's pointed at the target, and then it has a tangent line that goes all the way to the target. So this is where we would define our build. And I'm going to put in 3 degrees per 100 here. And now I'm going to execute a projection here. So in order to execute a projection, I hit the right mouse button. The right mouse button allows me to choose any point around this target that I want to hit. If I want to hit left, right, wherever. Now if I am going to try and hit, I can even hit targets way over here using that, and there's hardly a target that I can't reach from where I am, which is about 500 feet down. But if I am at 500 feet, I believe, in my surveys, and I'm projecting from that point to a point that's 8,000 feet down, and then the point that I'm selecting is the point that I'm clicking right here. So if I want to zoom in a little bit and get a tighter view on the target so that I can say more specifically choose this point of the target, I can do that. Or I can come over here choose this corner, or I can choose this corner, this corner. But let's say I want to do something different, and I want to have precisely, I want to be able to hit any exact point in here. Well, without me choosing the point with my mouse, I can't really get to exactly the precise point that I want to be at. It's just always a little bit different because of the inaccuracies of how pixels map out to the logical space that we're working with. And so I have this down here where if I want to go to the exact mathematical center, I go here. And if I want to go to the exact left, I go here. Exact right, I go there. And the top left, top right, top center, bottom right, and bottom left. Now in this case we have a rotated target, so the way it went was a little bit different. It went to the actual coordinates of the rotated coordinates of that target. Normally this target would be rotated in a different fashion, and I'm going to come over here now and illustrate what I was talking about earlier when we put in the targets of how this target is actually rotated. So I'm going to go to the target over here. And remember, I wanted to rotate this target 45 degrees, and I rotated it by 45 degrees to the left by subtracting 45 degrees from 360. Well, 360 is the same as 0, so I'm going to put 0 in there. And I'm going to come back here, and now we can see how this target is rotated. And that's the way the targets are rotated by default in WinServe. So now that if I want to go to the center, or I want to go to the left, or I want to go to the bottom left, or bottom right, it makes a little bit more geometric sense what left, top, right, and center is. So that's a very powerful tool for us, and this is a very powerful projection. It's kind of a, if you're going to be drilling in slant wells, or horizontal wells for the most part, this tool and the many things that you can do with this tool is a tool that you will want to use quite often. Its limitations are that it doesn't allow you to hit a point at a particular inclination and azimuth. And for that, we have another tool, which is the vector projection tool. And that's the tool that we would use right here. It's also called the S-Well vector project tool. And we're going to choose that one now. And that's going to be a little bit different here. What we're going to do with this tool now is we are going to define the two dog legs that we want to use, because the S-Well, of course, has the dog leg up at the bottom, and it has the dog leg down further down when you turn into the target point. We're going to use 3s up here and 2s down on the bottom. And then we have an inclination and azimuth, which we have already defined. We defined those earlier on when we were putting in the target information. And recall that inclination and azimuth was the calculated inclination and azimuth that came from the first target to the second target. So in this particular tool here, I also have a thing called post hold, which is an extension that I can put in. It's how much footage that I would like to have before I actually hit the target. In other words, if I can get to 38 degrees inclination and 57 degrees azimuth 100 feet before I actually get to the target and hold that to the target, and that's what I would put in there, 100. So I'm going to press C here. Okay, now look what's happened. We now have this projection that goes out here and turns out and is pointed dead center of this target over here. If I go to the left, again, I'm going to the left of that target, right of that target. And in each case, the target is being calculated, and I'm pointing towards the center of it. That screen that just popped up there happens when I press the left button, and I'll explain that in a little bit. The other thing that we can do here is we can choose dynamic vectoring. And dynamic vectoring allows us to select a different point based upon the graphic here, so that if I wanted to hit the top, and what the dynamic vectoring does is calculate the inclination and azimuth from that point down to the target, because it changes, of course, depending on where we are. And so I can come up here and I can choose that, I can choose that, any target that I want, and I can go dead to the center, or I can go dead left, and it will be calculating down to the center of this target. I'm going to go ahead and hide this box right here just to get it out of the way, and I can get it back by hitting the show box button again. And now what I'm going to do is do a graphic target, or basically what I want to do is select the point around this target that's different from the center. And let's say I want to skirt the left edge of this target over here as opposed to hitting the center of it. And I'll zoom in a little bit and get a little tighter view on it. And then I hit the left button on the mouse, and it asks me if I want to set a graphic target. And I say yes, and it pops this screen up, and it gives me the ability to type in a precise coordinate that is more precise than the one that I picked with the mouse. But I'm happy with this. This is, as many things in directional drilling, it's a good estimated point. And so now when I calculate my points along here, I'm no longer going to be pointed at the center. I'm going to be pointed at that point that I chose up here. So I'm going to choose top left center, and we're going to say that we're actually trying to avoid this first one, and we want to avoid that as well. So I've created a pretty sophisticated survey here, and then I could have had a discussion with a geologist or somebody, or a drilling engineer at the same time while I was deciding how to do what they wanted me to do. And instead of me having to go back and recalculate all these numbers and go through a laborious process, it's been turned into an easy-to-do graphical process. I'm going to do one more thing here. I'm going to give myself a 100-foot extension, or I'm going to give myself a 500-foot extension just so we can see it a little bit easier. And notice, keep focus on what happens with this curve when I press this TL over here. And you can see that I have now a 500-foot extension from where I actually had achieved the inclination and azimuth that I needed to hit this first target. Okay, so now we're done using that, and we're going to go copy mode curve to 23. And it's an important thing to do if you want to keep your projection so that you can see what you've done with it. So I go to 23, and there was a message on there that said that it not only copied to 23, but it was copied to 21 as well. And so now we're coming over to curve 21, and we can come down here and we can see everything that has transpired with this particular projection. We started out at 3s up at our survey point of 500 feet, and then we projected on down till we had pointed towards that second, the tangent section there. And we hold that tangent section for many thousands of feet before we come to a point where we start a 2-degree turn, and we achieve the inclination and direction that we want to use 500 feet before we actually get to the target, and we hold a tangent to the target for the first target. So this defines for us everything to the first target. What we don't have is a projection to the second target. So to do that, we stay on curve 21, and we determine that by looking here over curve 21, what curve we're on. And I'm going to come over to here, and I'm going to do a straight line to TVD projection here. So I come to straight line to TVD projection. And I come down and I click on the second target at 9,500 feet, and it executes a projection for me. It should have executed a projection for me. Let's get out of there. That didn't work. Okay, we're going to do that again. Let's go to straight line to MD. Okay, maybe we have to come up here. Okay. Come back here again, hit this straight line to TVD. Click in here, click there. Okay. For the first time, it didn't register the inclination and azimuth, so I had to click up into here to get it to register the TVDs. And now I have a projection that goes down to 9,500 feet, and I have to add that. We're going to go over more of these projections in a minute. But you always have to add that, and that adds it into curve 21. So now I have this projection that goes all the way down to 9,500 feet. And when I go to my plot and get my plot adjusted in the right way, we'll be able to see all that stuff. And I'm going to turn on my curve 21 projection. Again, we're going to be discussing the plots in greater detail here. For right now, you can see that I'm going to put this at 200 feet here. Adjusting, I need to click on this curve right here, 200 feet. I'm going to reduce the number of ticks here, or increase the number of ticks here so that I can see my other targets. And as you can see here, we have a hit. And we'll just go from composite to horizontal here. And you can see that this whole curve's been planned. It's hit that corner right there and is just hitting this circle down here tangentially, which is exactly what we wanted to do. So that's a useful, very useful tool to use. Now we're going to go ahead and explore some other tools here, and we've already used the tangential tool. And the first thing we're going to do, though, is notice that we're in curve 21. So we can continue to do projections. We're going to be projecting from the end of curve 21, and we actually want to project from the end of our work curve. So we're going to click here, and our work curve is going to be selected. Not only do we want to project from our work curve, but we also want to be able to project from our projection to the bit. So I'm going to turn this on here, and this is going to make a projection to the bit, and so the projections that we're going to make are going to be made from this point here as opposed to this point at 500 feet. We're going to be projecting from 556 feet. We're going to come up here, and I'm going to just do a straight line to MD projection here. And you notice that on the left-hand side of the screen we have the tie-in point. On the right-hand side we've got the projection point. And in the middle we have the parameters that we can use to make our projection with. So you have, for this particular projection, you have a measured depth, and I can define it. My measured depth right now is at 556 feet, and if I wanted to add 100 feet, I could come down here and go 100. But if I wanted to use a total projection MD, I could come into here and I could go 800 feet, for example, and it automatically calculates the added measured depth that I need to have, and then it makes that projection for me. And again, I can go ahead and add that if I want to and look at it in curve 21, and we can look at that in the plot, and we can print those out in the reports. But I've got another thing where we can do here, and that's to do the TVD projection. The TVD projection is organized exactly like the measured depth projection, except that when we come up and we choose our total TVD, it's choosing our tie-in TVD at 555.99, and if I wanted to go to a TVD of, I wanted another 100 feet here, I can do that, and it goes down to 655.99. If I want to go to, say, exactly 800, a TVD of 800 feet, I can put in 800, and it calculates for me the exact amount that I need to get to 800 feet in the added TVD program. So I can do either or. there. The other thing that I can do is if I have a target point, often the TVD that we want to go to is the TVD of a target that's already been defined. And instead of us having to bother with typing in that TVD, we can simply come down here and we can click on the target and it will automatically add the projection for us. And then it'll execute that. Again, I've got to. There's some. Okay, there's a little bit of a bug in this TVD thing here. Apparently, you have to, when you come into it, you need to click on this first, and then you come down and you click on it, and it will execute it. I'll see if I can fix that. But the thing is that if we wanted to continue on with that survey, we can just go ahead and add there, and we'd be done. So the other projections that we have here is we have Build and Walk tool as well. And Build and Walk tool is not a tool that I like a whole lot, although it does have some nice features to it. We have a total MD, an added MD, and we can have walk rates and build rates. Well, probably when we go and we add a little bit more build to our curve later on, we can play around with this tool. But with a powerful tool like the DLS projection to target, using a tool like this is really pretty silly. I guess you could use it for saying that if you wanted to hold angle and you wanted to see how much you were going to walk over 1,000 foot or something like that, you can use it there, and it calculates what you need to have. So it does have its uses. It has a couple of options down here. This point to target is an interesting one to use, because what it allows you to do is put in your walk rate, and it will hold angle and turn to the target for you. Sometimes that has a use in specific instances where you're kicking off and you're, say, pretty much in the opposite direction of the way you want to go, but you've already achieved 4 or 5 degrees of angle, and in the straight section it's just drifted off, and what you want to do is you don't want to lose that angle, you want to maintain that angle as you turn. And so there's a way of doing that, and you basically generally will turn your tool face over to about 91 degrees as it turns out, and just keep on holding that angle as you come around and point to the target. And this walk rate tool will help you do that. Then the other tools that we have in here, you come down here, this inclination and azimuth at TVD is one that's based upon something which we're going to not discuss right now with horizontals, but we're going to move on to the Ouija board calculator. The Ouija board calculator is a very powerful tool, and you can only get to it from this screen here. This is the tool that allows the directional driller to answer that question that says, well, if I drill for 30 feet with a tool face of 45 degrees to the right and a dog leg of 3, where am I going to be? It answers that question. It is also it also answers other questions, like, okay, if I'm going to get to a particular inclination and azimuth with a particular dog leg, what am I going to have to do in order to achieve that? What tool face am I going to have to use? So we're going to start off here by saying just where are we going to be in 30 feet if I have a dog leg of 45 degrees to the right, or I have a dog leg of 3, I should say, and a tool face, a high side tool face of 45. And it makes that projection for me right there. So I can see this number over here, and I can do whatever I'm going to do with it. There's another option that I can do, and sometimes it's a good idea when you change modes in this tool to leave the tool and come back into it again, because it has a tendency to get a little bit squirrely if you don't do that. So this time I'm going to use the DLS of 3, and I want to be at a final inclination of 14 and a final azimuth of 135. Okay, so bang, it tells me exactly what I need to do. It's told me that it says magnetic tool face, but that's actually not right. It's gravity tool face. And that's what I'm going to need to do. I'm going to come back and do one more projection with the Ouija board calculator, and that is going to be based upon a TVD projection. And notice that my TVD right here is 556 feet about, and I want to go down to 800 feet, and I'm going to use a 3-degree dog leg and 0 tool face. And it tells me if I continue to do that, to get there, that'll be my inclination and azimuth. So what I can do here is, well, let's say I want to do 10s. What's 10 going to do for me? I can do 11s. You can play little what-if games here. If I wanted to find out what I needed to do to get to, say, 90 degrees, I could keep on going up. I can try 20s, for example. That's not going to. Let me try a 30 there. Let's see what a 30 does. 30 gives me way more than I need. Let's try 25. 22, 23, 23.5, that's going wacko, 23.1, 23.15, 23.2, it's got to be a better. Now let's go ahead and make our first graphic projection. Notice that when you come into the screen, you'll always see this up here selected. This is the projection type that's up here, and it's your DLS mouse is what it's set to normally. You can move it to different ones, but we're going to keep it on this right here. What this does is make a slant projection. This is the area where we adjust the parameters that we want to use for that projection. And for the DLS projection, what we want to use in this case is 3. So if you wanted to use something else like 2.5, you could go ahead and just tap in 2.5. Conversely, you can also change it by a 1/10 of a degree by going ahead and hitting these arrows. So I've got it back up to 3 here. What I want to do is make a projection to the center of the target, and I can do that most easily by coming over here to the projection point box and clicking C. This box of buttons here represents the various points around the target, and you have, these would be the 4 corners of the target that you could shoot for, and this would be the left and the right, and this would be the top center and the bottom center. I'm going to put it back on the center. Once we have the target projection made the way we want it, we can copy it over to curve 23 and 21, and we will put it over here. And then we just go ahead and go back to the main screen here, and we can see in curve 21 that we have in fact executed that particular projection. And that's all there really is to doing that projection. If we want to see it in the plot, we go to the plot and we make sure that that curve 21 is turned on in the plot. I realize we haven't gone over the plot at this point, but I'll assume that you probably know how to use it by now, or will soon learn how to. The next graphic projection we're going to cover is the S-well vectored curve projection. And that is a projection which is also available in the curve 21 projections, and in there it's called the vectored project to target. Both of these projections are very powerful. They both offer different capacity because of the nature of the interface. We're going to start off with the projection, graphic projection here and we're going to select the projection button. And this should by now look somewhat familiar, and the first thing that we're going to do when we enter this screen, as we should always do, is select the projection that we wish to use. And in this case, the projection that we wish to use is the S12 vector projector. So we pop that up, and we can see the little dialogue here that's popped up. I'm going to use this little box right here and minimize this box, and we get it back. We'll hit this show box button. But we have one more thing that we need to do before we start using this, and the thing that we have to do is adjust the zoom here, as you should always do, so that we can see where we're at and where we want to do. As I mentioned earlier, we have a target. We have a target here, a primary target that we're headed towards. The red crosshair represents where we are, and this is a secondary target that we want to be aligned to. So we want to go from here to here, and when we arrive here, we want to be pointed directly at the center of that target. So we can confirm in our mind here that, of course, this is the first target because it's the one in the middle. And so what I'm going to do here is I'm going to bring back our interface box for this, and we'll note that what we want to do is turn, say, with 3s up at the top, so we're pointed generally towards the target, and then we're going to use a 3-degree dog leg once we get down near that target, and so that we can turn and point towards the target. And then we have an inclination and an azimuth here. Now with this particular tool, I'm not sure whether this inclination and azimuth is in fact accurate or not. I think it may be, but I'm going to find out very quickly, because all I have to do is press C, and it'll go ahead and make the curve for me. If I turn on dynamic vectoring, that is, it will do it. So I press C and I turn on dynamic vectoring. Dynamic vectoring is what the flag is that tells the program to take the point of interest and calculate the inclination and azimuth from that. And you can see that when I press C, that after selecting this dynamic vectoring, that there was in fact a correction made to the inclination and azimuth. Now I can come over to here and I can press the right mouse button to execute the projection at any desired point around the target that I want. And so that's where the real power of this comes in. One, that I have good visualization and good feedback on what's happening, and two, that I can select targets other than the target that is defined in the database by simply right-clicking on the mouse. Now, if I want to take this line and extend it to the center here, what I have to do is I have to add another projection, and I do that with the Curve 21 projections. But I'm going to go ahead and explain a couple more things here first. One, what this post hold is. I'm going to put a number of 500 in here, and I want you to take a close look at what happens to this curve right here when I do this calculation. I'm going to press C again so that it goes to the center of the target. And what you can see is that there is a straight line now that goes from, that's 500 feet long, that goes from the end of the curve into here. So what this does is allow a directional driller to make a plan so that he has a little bit of catch-up space and to be able to achieve the inclination and azimuth that he wants to have by the time he reaches the target. These little arrows here are for moving this box around. If for example, you wouldn't want to have the box right there or here, so it's either here or here is where you'd want to have the box when you're doing a projection using this tool. Or you can just hide the box and the settings are still active and things are still going on inside the box, just that you can't see it. Again, these controls down here are for positioning around the target. exactly the same as they were with the slant tool projection. When we have everything as we desire, we hit this copy mode curve to 23, and it also, you'll get the message that it's copied to 21 as well. I'll do that right now, and we get this message that curve has been copied to curve 21 and curve 23, blah, blah, blah. So we go OK and done. And so we come over here to curve 21, and now we can see that our curve has been built with 3s, and we have a long tangent section in here where we come down towards the bottom and we have to use 3s again to turn and align to the target. And we can go to our plot, and we can see that we have indeed have that curve there. If we wanted to extend this plot, or this curve here, down to the center here, and say that we were going to make a proposal, what we would do at this point is select curve 21, because now we're going to make a projection from the end of curve 21. And the projection that we want to make is a TVD projection. So we come over here to curve 21, and we do a straight line to TVD projection. And it comes up with the tie-in point that we have on the left. And on the right-hand side, we have our projection point, which is yet to be calculated. And all we really have to do at this point, when you enter the screen this way, is click on this target down here, which is the bottom target at 9,500, and the program will automatically calculate everything for you. And you can see that the point is the point that you want, and then you can go add. We'll be doing more curve 21 projections in a few minutes, and there'll be more explanation on how this screen works. For now, we can just go add and go done, and then when we go take a look at the plot, we can now see that our projection has been extended from the first target down to the second target. Now is a good time to explain how we can take that curve in curve 21 and turn it into a proposal. It's essentially a proposal as it is right now, but in this case what we want to do is we want to move it from 21 over into curve 1 so that we're not going to we're not going to destroy curve. We're going to destroy curve 21 each time we do a projection, so we can't very well have a proposal if we keep on destroying it. Now you might think, well, the most logical Windows way would be to hold this button down and then drag it over to here and pick it up, and then you would have moved all the data over there. And that is indeed a very nice interface to do, and it certainly is possible to do it with regard to the way this program works. However, when you do that, you can accidentally move curves around, and it's not something you want to do. So I've made it a little bit more obtuse to move a curve. And what you do is you go to Edit, and you use Curve Editor. And when you come up with Curve Editor, it gives you two sides. And on the left-hand side, you have a curve, and curve 21 has already been selected for us. And on the right-hand side, we have a set of 30 buttons, and we can select the curve to where we want this copied, and we click 1. And then we can go press the copy button, and it is executed for us. And so we can see over here in curve 1 now, we have this curve. This is a useful tool, and it's how you would go about creating any proposal using curve 21. We'll have a discussion on well planning. It's probably one of the last things that we do in this whole lesson plan. But most users of this program don't have the well planning button associated with it. It's a special license in order to get that well planning button turned on. So at this point we can return to our projection here, and again we back out and we come back down to here, and we'll take one more look at things that you might want to do with this tool. First thing you do is now what we are going to do is begin making a study of the Ouija projector. And the Ouija projector is a projection that you can get to by going to curve 21 and then going a few items down and choosing the Ouija board calculator. This projection allows a directional driller to determine where his motor will be after drilling, say, for 30 or 50 feet, given a particular dogleg tool face. He can, in this case, see on the left-hand side here what his tie-in point is, and on the right-hand side what his projection point is. And if he wanted to know where he was going to be in 30 feet, he would just put in 30 and put in the dog leg that he wanted to work with, say it was a 3-degree dog leg, and a tool face of 0. And you can see on the right-hand side what the inclination and azimuth and the coordinates are going to be. If he wants to change his tool face to say something like -90, he can do that, and then it will show him where he's going to be with -90. And when he wants to go ahead and have that survey added to his projection, he presses the Add button, and then he can press Done. And when he adds it, it's automatically put into curve 21. I'm going to click 0 again because this is the curve that I want to project to. But if I wanted to continue making projections from curve 21, I would stay on curve 21, and then I would come over here to curve 21 and select the projection tool that I wanted to use. But I'm going to go to curve 0, my work curve, and that's the curve from which I'm going to continue to make projections. So I'm going to get back to the Ouija board calculator here, and I'm going to evaluate another solve mode of the Ouija board calculator. The mode that we just did is called the MD mode, and the mode that we're going to do right now is called the DLS mode. The DLS mode, we can specify a dog leg and an inclination and azimuth that we want to be at. It's kind of like calculating a survey but backwards by telling it what you want the inclination and azimuth to be, and then it's going to tell you what your measured depth is that you need to have. Anyway, the final inclination in this case, we'll say we want to have it at, say, 5 degrees, and we want to be pointed in a 45-degree direction. So I'm going to put that in. Now I hit the Tab key, and we can see that the measured depth at which that will occur is 713 feet. We have to drill 157.3 feet. And we need to start out with our tool face a little bit left, about 13 degrees left. And this is the survey that we can expect to see at the end of that 157 feet that we would drill. I'm going to go ahead and add this now. And then again, I'm going to leave the screen, come back, and we'll take a look at what happened to curve 21 here. Curve 21 has now been overwritten by this new projection. And we can look on the screen here, and we can see that we indeed did have a 3-degree dog leg that went down. And we can see that our tool face started out at 13 degrees. And then in 30 feet, we would back it off to about -3 degrees. And essentially hold it straight up. I mean, you probably can't hold your tool face much more accurately than that. But the important point here to understand is that these minimum curvature calculations will always give you tool face is to tell you to make these turns in which the tool faces actually vary across the beginning. You wouldn't hold -13 all the way through, because -13 all the way through is going to give you a very different kind of projection. But we can see how we would come down here, and we're at 5 degrees and 45. Okay, so I'm going to, again, okay, now we're going to go straight to curve 21 projections, and we're going to go over the easiest projections in the whole pile of projections. We're first going to use the straight line MD projection, and we've used that earlier, or TVD. They work both identical, and I'm only going to cover this one because the other one's the same. But this one, you have on your parameters list, you have the total MD and the added MD. And if you know that you want to know where you're going to be, say in 30 feet, you would just go ahead and put in 30. And then hit the tab key, and then the projection will be made down 30 feet deeper. If you knew that what you wanted to do, say, at exactly 700 feet, then in the total MD you would put in 700, and the program would calculate the added MD necessary to get there and then do the projection for you. And if you want to add that projection, then you just press the Add button, and the surveys will be generated for you over here in Curve 21. Now we're going to go over some of the projections here that we have discussed earlier here. The DLS projection target, which is the slant well projection that we had graphically. What we're going to have here is a bit different of, first of all, I'm going to get out of here and select curve 0 because I could see that I was still in curve 21. And I want to come over here and project from the end of my work curve, not from the end of the projection curve. So I have curve 0 selected. Coming back to here, getting back into this discussion, we are now, as I can see here, projecting from the end of the work curve. And this is a target-oriented projection. And in the center here, I can click on this target number to see what target is currently selected. And if I wanted to choose another target, I can just come down here and select it directly from this list that's below me. But I want to go to 8,000 feet. And now I click here to curve 0, or to DLS, and I see that DLS is 0, and I can see my projection point over here, and I follow this down here and I look at the dog leg, and the dog leg is 0.35. While when the DLS is less than that, which is, you can possibly get there with a minimum curvature calculation, the program calculates what the minimum curvature calculation is and then displays what you would have. Now there's an interesting thing here. When you do a minimum curvature calculation like this, you can see what the inclination is, and minimum curvature will generally have the highest inclination in directional that you can get. So you get 27.42, and then the other limit on it would be, say, something that was basically a straight line from the point where you're at to the inclination to the target. So if I want to approximate a straight line, I can put in a very, very high dog leg here. I'll put in something like 1,000 dog leg severity that I want to have here, and it shows me that the inclination is going to be 13.85. This dog leg down here now says 0 because I have a lot of straight line, and straight lines of course have 0 dog leg. So I know now that I have the ability to create a curve that has a variation between an inclination of 13.85 and 27 point whatever that was. And the important thing where that comes in invaluable is when I'm trying to use this functionality down here to solve for dog leg. I'm going to get out of here and come back in. And the reason I'm doing that, quite frankly, is because sometimes the program can be a little bit sensitive when we are in the process of changing a lot of parameters around. So it resets it when you come in. And I'm going to come over to here and notice that the first thing I did was I choose solve for dog leg, and now I'm choosing the target number that I want to go to. And now I'm going to put in an inclination that I actually want to be able to strike the target with. And I'd like to be able to strike the target with an inclination of 20 degrees, and then I can see that I need this ridiculously low dog leg in order to do it. And I can try something like 15 degrees if I want a nice round number, and I should have a 1.22, which is a more reasonable kind of dog leg to think that you can possibly control. At any rate, that's how you use these tools, and these tools are, this particular tool is a very valuable tool when you want to have a horizontal well and you're kicking off and the geologist or whoever keeps on changing the angle a little bit about what the final inclination is that you want to have. And you're going to have a 91, no, it's going to be 93. And when you do that, this is a very quick way of figuring out what your needed build rate is to get down there.